This video is on question 37 from the 2013 IMAT paper. So in this question, we're shown this pedigree diagram and told that boy C has a genetic condition, and no other member of the family shows the same genetic condition. And we're asked which one of the following could not explain why boy C has this condition, and we're given this list to choose from. So let's start with the sex-linked dominant condition. So if this condition, this genetic condition, is a sex-linked dominant condition, then the genotype of boy C must be XA, with A being the dominant allele for this gene. Let's call it gene A, which causes this genetic condition. So XA, Y. And therefore, if boy C has this XA, that means this allele must be provided by either his father or his mother. Therefore, his father must have had that genotype, if he is the one that contributed this allele, or his mother could have had either of these two genotypes, heterozygous or homozygous dominant. However, we can see that neither of the parents are shaded as boy C is, so neither of them have this genetic condition, meaning this it can't be the case that this is a sex-linked dominant condition. So now we know that A is our answer. So you can continue watching if you want to see why the other answers aren't. Why the other answers, can explain why the boy has the condition. So our answer is A, but I'll move on to addressing the other points now. So option B is a sex-linked recessive condition. So if this is the case, then the genotype of boy C must be XA, Y. That is, he has this one recessive allele. And as he is a male, he doesn't have a second allele for this, so the genetic condition is expressed. So if this is the case, we can see that his father does not have the genetic condition, and so his genotype must therefore be this. He has this capital A. Therefore, the mother must be a carrier of this recessive allele, and it was this recessive allele here which was passed to her son, giving him the genetic condition. So C, both parents are carriers. So now the condition is no longer sex-linked. So as the boy has the condition, then this means the condition could be recessive, and so his genotype is homozygous recessive. Therefore, this could come about by each of his parents being heterozygous for this gene, and so boy C has inherited a lowercase a from both parents to give him this genotype, which gives him the genetic condition. So D, autosomal recessive condition. So what does this autosomal mean? Well, an autosome is just one of your non-sex chromosomes. So your sex chromosomes being two X's for females and XY for males. So autosomes are the remaining chromosomes. And so this situation actually has the exact same reasoning as the previous point, where if it's an autosomal recessive condition, the boy C must have this genotype, homozygous recessive, and therefore he could have inherited these two alleles without either parent showing the genetic condition, by both of his parents being these heterozygotes, these carriers of the autosomal recessive condition. And finally, mutation. So how could this explain why boy C has the condition and neither of his parents do? Well, we can explain this firstly in a situation of when the genetic condition is caused by a dominant allele, and after that I'll explain how this could come out if the condition was recessive. So, if the genetic condition is caused by a dominant allele, but neither of these two parents have the condition, then they must both have a homozygous recessive genotype. However, if boy C does have this condition, his genotype must be either homozygous dominant or heterozygous. Therefore, as neither parent had one of these dominant alleles, a dominant allele must have arisen through mutation, and this mutation converts one of the recessive alleles into a dominant allele. And so, for this if the boy C is a heterozygote, then one of his parents' recessive alleles mutated to become this dominant allele, and if he is homozygous dominant, then both of his parents had a mutation in their alleles, converting this recessive allele into the dominant allele. So, if now instead this genetic condition is caused by recessive allele, then we know boy C's genotype must be homozygous recessive. Therefore, even though neither of his parents are have the genetic condition, this could arise through mutation through this situation. So, say one parent, the mother in this example, is a carrier, and the other parent, the father, does not have the recessive allele at all. However, if there is a mutation converting one of the father's dominant alleles into a recessive allele, so that the father is now a heterozygote as well, then each parent could contribute a recessive allele to boy C, therefore giving him this homozygous recessive genotype, and therefore giving him the genetic condition.